Hello. So today we're going to do our 9.1 part 2 notes. Just a reminder, we actually didn't quite finish the 9.1 part 1 notes on Friday. I attached them to these notes and hoping to do them today, but since I can't be there, my daughter's sick, we'll probably do them tomorrow. So just remind me if I forget. So what we're doing today is we're simplifying radicals. Remember, radicals are roots with variables under them, so the process is a little bit different. So to simplify radicals with variables, we want to divide any even exponent by 2. And then we want to break apart any odd exponent by separating one base. So I'll kind of show you the difference between the even and the odds. So for even, the square root of the x to the 4th, under that root, you just take the exponent, which is 4, and you just divide it by 2. So it's x squared. The reason for that, I'm just kind of showing you why underneath. You don't need to write this down, but just to show you, if I went back to square that x squared, if I took x squared times itself, remember the exponent rule is to add those exponents, so it would give me that x to the 4th. The next one is x to the 5th, so it's an odd exponent. 5 is not divisible by 2, so I want to break it into x to the 4th times x to the 1st, because I want that exponent to be divisible by 2. So the square root of x to the 4th is x squared. So that can come like out of the root. And then under the root, I just have the square root of x to the 1st, or just x. Okay, so on these next ones, we're just looking at even and odd exponents. And then going through some examples. Okay, so the square root of x squared, 2 is even. So I just want to divide that exponent by 2. So 2 divided by 2 is 1. So the square root of x squared is just x to the 1st, or just x. N to the 3rd. 3 is odd, so I want to break that root into n squared times n to the 1st. Those exponents need to add to 3. So 2 plus 1 is 3. The square root of n squared is n, so I can just take that out of the root. So I already accounted for that, so I'm going to cross it off. The only thing left under the root is n to the 1st, or just n. The next one is a to the 5th. So similarly, 5 is an odd number. So I want to break that up into a to the 4th times a to the 1st. The square root of a to the 4th, just cut that 4 in half, so it's a squared. Sometimes I cross it off after I dealt with it. And then I just have an a left under the root. The next one has an x and a y in it, but the idea kind of remains the same, where you want to just divide those exponents by 2. So both of them are even, so I can just divide them both by 2, no need to break it up at all. So the square root of x squared y to the 8th, 2 divided by 2 is 1, 8 divided by 2 is 4. I don't really need that 1 on the x, so I'm just going to write it like that. So moving on, the next row, I just started drawing on here for no reason. On the next row, we have some that have more than one variable in them again. So this one has an x, a y, and a z. So the exponent on the x is not even, so it's not divisible by 2. So I want to break it into x squared and x to the 1st. The y is fine. You can put a dot in between those, or you don't need to. The 6 is divisible by 2, so we're good. This z has an invisible 1 on it. It's going to have to stay under the root because we want it to be divisible by 2, but it's just too small, so we have to just leave it. So the square root of x squared, this first term, is x, so I can bring an x out. That next x, this one that I'm underlining, is going to have to stay under the root. The next one is y to the 6th. 6 divided by 2 is 3, so you can pull that out. And then this z has to stay under there. So that should be your answer on that one. The next one is x, y to the 9th. So I'm going to break up. I'm going to leave the x. It's x to the 1st, so it's just too small. You can't, it's going to have to stay under the root. And then I'm going to do y to the 8th times y to the 1st. So the x needs to stay under there. The square root of y to the 8th is y to the 4th. And the y needs to stay under there too. The next one is x to the 4th, y to the 5th. So I'm going to break them up first. So I'm going to make the 5, 4, and 1. The square root of x to the 4th is x squared. The square root of y to the 4th is y squared. And then that y needs to stay under there. The next one is a to the 7th, b to the 5th. So break the 7 into 6 and 1. Break the b into b to the 4th and b to the 1st. So 4 and 1. The square root of a to the 6th is a to the 3rd. It comes out. That a needs to stay under the root because it's a to the 1st. The 1 is too small. It's not divisible by 2. It's got to stay under there. Square root of b to the 4th is b squared. It comes out. And then that b stays under the root. There's some u tries there too. So kind of using the same idea we've been doing. Why don't you go ahead and try those? And I'll fill them in and you can check your answer. So just pause the video for a minute while you try them. So these are the answers for those u tries. So x to the 7th, I had to write that into 6 and 1. And then I was able to pull out an x to the 3rd. N to the 8th, 8 is already divisible by 2. So it's just n to the 4th. This x to the 3rd and y to the 10th, I had to break the 3rd into 2 and 1. And then the 10 is already divisible by 2. So it's fine. And then the last one, I had to break the 3 into 2 and 1. The 9 into 8 and 1. And then that c needed to stay under the root. So if you want to go ahead and pause the video for a minute just so you can get those down. I will upload a notes key on Google Classroom later too. So now we're moving on to radicals with variables and numbers. So on this page, we will see variables and numbers under the root. So it says if the number is a perfect square, just take the square root. If it's not a perfect square, you have to break it apart and simplify like we did on Friday. So the square root of 9x to the 10th, 9's already a perfect square. The square root of it is 3. And then the square root of x to the 10th is x to the 5th. That's what we've been doing today. 20 is not a perfect square. So on this one, I actually usually take one step where I just break up the 20 into 4 and 5, because 5 is a perfect square. X to the 5th, I'm going to break in x to the 4th times x to the 1st. And then just pull out the perfect squares. The square root of 4 is 2. Square root of 5 needs to stay under there. Square root of x to the 4th is x squared. And then that x needs to stay under there as well. So these bottom ones are just trying that on a bunch of different examples. So the first one, 49 is a perfect square. So the square root of 49 is 7. Square root of x to the 8th, that's what we're doing today. Just cut it in half, so it's x to the 4th. The next one, 16 is a perfect square. But this 3, that's not an even number. So if I have anything that's not even, I take one step where I just break it up. Square root of 16 is 4. Square root of x squared is x. Sometimes I like to highlight or cross off or something when I've already dealt with something. So I already dealt with both of those that I'm highlighting in green. The square root of x to the 1st, that's going to have to stay under the root because it's not, can't break that 1 down. And then the square root of y to the 4th is y squared. So it comes out. So that should be my answer there. It's kind of how you do all of these. So you're just breaking them into perfect squares for the numbers. And then for the exponents, you're breaking them into something that's divisible by 2. So 40, we want to be thinking of our list of perfect squares from Friday, which hopefully is kind of in your mind. We want to use 4 times 10. A to the 19th is a to the 18th times a to the 1st. Square root of 4 is 2. Square root of 10, it's not a perfect square. Square root of a to the 18th is a to the 9th. Square root of a needs to stay under the root. And the next one is square root of 25. That's a perfect square. X to the 6th, also a perfect square because 6 is divisible by 2. But 13 is not even, so we have to break it down. So I'm going to take a step where I just break everything down. Those two are fine. The 13, I'm going to make 12 and 1. Square root of 25 is 5. Square root of x to the 6th is x to the 3rd. Square root of y to the 12th is y to the 6th. Remember, divide by 2. And I'm left with a y under there. 63 is not a perfect square. So make it 9 times 7. The b squared is fine. Square root of 9 is 3. Oh, square root of 7 we don't know. Square root of b squared is b, so I got to squeeze a b in there. Square root of 27 n to the 3rd. I'm going to make the 27 9 times 3, because 9 is a perfect square. I'm going to make the n to the 3rd, n to the squared times n to the 1st. Square root of 9 is 3. Square root of 3 is not a perfect square. Square root of n squared is n. That n to the 1st needs to stay under the root. 18 x to the 3rd, y to the 4th. So break the 18 into 9 times 2, because 9 is a perfect square. Break the x to the 3rd into x to the squared, or x to the 2nd times x. And then y to the 4th, 4 is already even. Square root of 9 is 3. Square root of 2, we don't know. Well, we do know it's like 1.4, but it's not a perfect square. The square root of x squared is x. That x needs to stay under there. Square root of y to the 4th is y squared. The next one is square root of 28, x to the 8th, y to the 9th, z. So break the 28 into 4 times 7. X to the 8th is fine. Make the y to the 8th times y to the 1st. Square root of 4 is 2. 7 stays under there. Square root of x to the 8th is x to the 4th. And you can pull out a y to the 4th. The y and the z need to stay under the root. And then just one more. We have 90, a squared, b, c to the 5th. Make the 90 9 times 10, because 9 is a perfect square. Make the c to the 5th, c to the 4th times c to the 1st. Then just pull out everything that's a perfect square. The square root of 9 is 3. 10 needs to stay under there. Square root of a squared is a. b needs to stay under there. Square root of c to the 4th is c to the 2nd. And then that c needs to stay under there. So that is that. You have some homework as well. If you need to pause this to finish copying the notes, like I said, I will upload them to Google Classroom later as well. The homework also has the homework from Friday that we didn't get to copied on it as well. Don't worry about that. Just do the homework from today's stuff. So the roots with the variables and everything. So tomorrow I'll check your homework from Friday and today. I think that's it. So work on your homework now. Hope to see you tomorrow. Bye.